a little bit too, there are too many parts to it to really do in time and get submitted. So the second problem of our exam asks us to find the volume of the solid generated by revolving the region bounded by the graphs of equation y equals x squared plus 1, y equals 0, x equals 0, and x equals 1 along the y-axis. So if you remember from the beginning of our class, the formula for, well, before we even get to that, of the solid, let's just graph it. We don't need to graph much because the bounds are not that much. So create an asymptote on the x-axis, create an asymptote on the y-axis, and create a border on the y equals 1 line, y equals 1 axis. And from this point on, okay, so it only goes up to y equals 1, so let's do a little coordinate table here. So if we plug in the x values of 0 and 1, for y, we're going to get 1 and 2. So, okay. That doesn't look right. Oh, my bad. Okay. So that I screwed up the when copying the problem down. I actually screwed up the bounds that are actually part of the problem, because the bounds that are supposed to be part of the problem are y equals x squared plus 1, y equals 0, x equals 0, and x equals 1. So now I got the right bounds. So x equals 1 is going to be right here. And because this is being rotated about the y-axis, we're also going to create an next border at x equals -1. So now we have our coordinates here. So when x is 0, y is 1. When x is 1, y is equal to 2. And that also goes for that direction as well. So this parabola here looks like it could form a cylinder. This is the calculus creativity that comes with practicing problems. You learn to see things that aren't there. Anyway, so now we got to use the shell method because we saw that this area is this volume is a cylinder. The formula for the shell method is as follows: integral from a to b 2 pi times radius times height. We don't have to worry about small and big radius because we're not dealing with a washer, so that's great. So our radius, so it doesn't, this formula, since we're going to write it out generally, we're going to add in the definite limits later, but starting out, you need to treat this like it's an indefinite integral. So you can't have any of the, so you can't have the radius or the height be a definite number. You have to have it as a function, because if you remember from our course earlier in the semester, we basically have to treat anything that has variable value as a variable. So if that's a better way of remembering it for you, then you could go ahead and remember it that way. So what that actually means now is that you got to imagine, if you're going from x is equal to 0 to x is equal to 1, if you want to find the volume at a certain, if you want to find the area at a certain point, you're going along the x-axis. That doesn't mean that your total area for the x-axis is 1, or your total radius for the x-axis is 1. That's not what that means. Remember, radius is a function. So depending on where you are, and we'll get to the actual limits in a second, but for the general formula, your radius is actually x. What about the height now? Height is given in the problem as y. So the height of our problem is just going to be x squared plus 1. Oh, there should be a dx here. Okay, and this 2 pi can come outside the integral. Volume equals. Now, what do we do about the limits? That's given to us too. Because we're not doing this about the x-axis, we're doing it about the y-axis. You got to go from your limits on the x-axis, which are given in the problem as x is equal to 0 and x is equal to 1. So you're going from 0 to 1. Now, the simplest way to do this is to multiply x into each of these values so that you don't have to deal with two separate terms. So you get x to the third plus x dx. Now so now you could actually separate out this integral because we're dealing with addition, not multiplication or division. So now you would have integral from 0 to 1 x to the third dx plus integral from 0 to 1 x dx. Now actually taking the integrals apart, we get x to the fourth over 4, limits from 0 to 1, plus x squared over 2, limits from 0 to 1. Now we got to plug in the limits. 1/4 minus 0/4 is obviously going to be nothing. Plus 1/2 minus 0/2, which is nothing. So we've actually got 3/4 in our parentheses, which gives us 3 pi over 2, because the 2 and the 4 cancel out to bring you a 1 and a 2. And that should be the volume of that cylinder, or the region, whatever you want to call it. It's fine by me. Third problem.